don't mess with me. And I should warn you that this has now altered my powers and I can read your mind. So don't even think badly of me. Okay, what's happening? We're building up so much electric charge on this ball that it's pushing off and trying to get away. Why wasn't I killed? That's something on the order of 250, 300,000 volts. It's a frightening number, but it turns out that total electric energy is dependent on A, voltage, and B, current. Current tells us how many charged particles are moving. Voltage tells us how energetic each one is. So we're saying that all the particles that move here are really energetic, but there are almost none of them moving. We should point out that the wire coming into this is only running a motor. No electricity coming off this ball came from Philadelphia Electric. This could have been, I could run this belt with hamsters in a cage if I wanted to, and it would work just the same. Okay? So all I have is static charge. Having endured 300,000 volts here, please note I am not grabbing a fork and shoving it in an outlet. A mere 110 volts scares the daylights out of me because there's lots of current and there's lots of energy, and that would kill me. Okay? So voltage alone isn't the biggest hazard. I mean, it's obviously dangerous. You don't want to bring your expensive computer down here. You don't want your digital camera in too close. Okay? But there's this isn't a really scary situation. It's uncomfortable. So the charge builds up on the ball until it's got enough energy to push through the air and find an escape route. Tell me what's going to happen when I turn that on. Yes? Okay, how come? Okay, they're light, but why aren't they flying off now? Okay, why are they staying there? What's keeping them there right now? Okay, gravity. And this is important. You know, it's important to kind of put the pieces together, right? None of it's magic. Right now, those plates are doing something that most things in the universe don't do. And that is they're sitting still. And they're sitting still because gravity's trying to pull them down, and the rest of the molecules between here and the center of the Earth are keeping that from happening. Okay, so there's a balance of forces and they're sitting still. What we're going to do is upset that balance. We're going to develop a charge on the ball. The charge is going to hate being with the charge. It's going to say, look, there's a conductor. I can get out of here. I'm going to the top plate. It goes to the top plate. The top plate builds up charge and builds up charge because it's touching. But as it builds up charge, it is repelled by the ball. The repulsion builds up and builds up. It doesn't happen right away. It takes a little time because we need the electric repulsion to finally get greater than the gravitational attraction. And when that happens, the plate lifts off. But what's interesting is, because they're conductors, the charge goes to the outermost plate and they lift off one at a time. You can actually watch the bucket brigade of charge as we carry it up get removed. Okay, and it's a very graphic portrayal of something that we had described theoretically, but I think it's really interesting to see. And in effect, the belt now becomes a conveyor belt that's pushing these things off. It's doing work.